Hello, lower secondary students. Today we are going to discuss a new topic, which is the highest common factor. How to find the highest common factor between numbers and between algebraic terms also. So let's look at our first example here. We need to find the highest common factor of the following numbers. We will take a couple of examples using the factorization tree. What do I mean by the factorization tree? The factorization tree is a method that we use to get each number as a product of its prime factors. So let's see. If I want to find the prime factors of 18, I need to find first any two factors of 18. We know that 18 is equal to 2 times 9. 2 is prime, so let's put that in a circle. Then we have 9. 9 is a product of 3 multiplied by 3. Both of them are prime, so I can say that 18 is the product of the prime factors 2 times 3 times 3. Taking consideration that we have to write the prime factors from least to greatest. Now, if I want to find the highest common factor between the 18 and 12, as we have in question A here, we're going to do the exact same thing with 12. So I have 12. 12 is the product of 3 times 4. 3 is prime, and 4 is the product of 2 times 2. I'm going to write 12 as a product of its prime factors. So 12 is equal to 2 times 2 times 3. Now, if I want to find the HCF, this is an abbreviation for it, or the highest common factor, we're going to do the following. We will look what's in common between the two numbers. I have 2 is common, so this is my first common prime factor, and I have also 3 here common. Is there anything else common between them? No. So I can just simply multiply 2 by 3 equals 6. Then I can tell that the highest common factor between 18 and 12 is 6. Now, can we do this mentally? Yes, we can. It is easy numbers like 18 and 12. But if I have higher numbers or I have more than 2 numbers, it gets more complicated. So let's do another example. What about solving f here? In f, we need to find the highest common factor between 36 and 54. We will write both numbers as a product of its prime factors. Now 36 is equal to 6 times 6. What if you choose 4 times 9? Will you get to the same answer at the end? Yes, we will. So you don't have to worry much which two factors did you choose. Now 36 is 6 times 6. Neither of them is prime. And 6 here is 2 times 3. 2 is prime, 3 is also prime. Here also I have 2 times 3, 2 is prime, and 3 is also prime. So I can write 36 as a product of its prime factors, which is 2 times 2 times 3 times 3. 54 is equal to 6 times 9, neither is prime. 6 again is 2 times 3, both are prime. And 9 is 3 times 3, both are prime. So I can tell that 54 is equal to 2 times 3 times 3 times 3. How do we find the highest common factor? Again, it's easy. I have 2 as a common factor, 2 and 3, no. I have a 3, and I have another 3. The highest common factor is the product of all the common prime factors, which is 2 times 3 times 3. That would be 2 times 3 equals 6, times 3 equal 18. So the highest common factor between 36 and 54 is 18. I'll solve one more, then let you do the rest as an independent practice. What if I have 3 numbers? I'll solve H here and I'll leave G for you to solve. We have 18 and we did 18 before. We can do it again. We have 24 and we have 30. 18 is 2 times 9. Let's do it in a different way and check if we are going to get the exact same prime factors or not. Now, we did it here as 2 times 9. Let's do it here as 3 times 6. Now, 18 is 3 times 6. 3 is prime. 6 is 2 times 3. Both of them are prime, so I know that 18 is equal to 2 times 3 times 3. If we compare these to the ones we got at the beginning, we'll find that they're exactly the same. So it doesn't matter which two factors you start with, at the end, you will only get the same prime factors. So that's for the 18. 24, 4 times 6, neither is prime. 4 is 2 times 2, both are prime. And 2 times 3, and both here are prime. So I can tell that 24 is 2 times 2 times 2 times 3. 30 is 6 times 5. 5 is prime, and 6 is 2 times 3. Both are prime. So I'm going to write 30 as well as 2 times 3 times 5. Now, if I want to find the highest common factor between three numbers, I am going to find what's common between all three of them. So I have 2 here, which is common between all three of them. So I'm going to take that once. And we have 3 as well. Well, I'm going to just circle it here. I can take the cross. So I have 3 as well. That's it. Nothing else is common. So my highest common factor is the product of these 2 prime factors, which is 6. So the highest common factor between 18, 24, and 30 is 6. Now remember, the prime numbers are, in case you don't remember them, 2, 3, 5, 7, not 9, 11, 13, not 15, 17, 19, 23, and so on. Also take in consideration that 2 is the only even prime number. So when you factorize and you get any of these, or you can even extend more, we circle it because this is the prime factors. Now I want you to pause the video and take the time to solve the rest of the questions. We have solved A, F, and H. You do the rest, then move on to algebraic terms. Highest common factor in each of the following. Now I'm going to do the exact same way. Now we know how to find the prime factors of numbers, so we're going to use that. Again, I'm going to solve the first one. I need to find the highest common factor between 18 and 24. Prime factors of 18, 2 and 9, as we agreed before, 3 and 3. So this is the 18. If I say 18x, so it's going to be 2 times 3 times 3 multiplied by x. What about 24? 24 is 4 times 6. 4 is 2 times 2. And 6 is 2 times 3. It's not only 24. It is 24xy, which is 2 times 2 times 2 times 3. This is for the 24. Then that is multiplied by x multiplied by y. So to find the highest common factor, I don't only consider the numbers like we did before. We also will consider the variables. I have 2 in common, so that's one thing. I have 3 in common, so this is another number. Then we have x in common. So the highest common factor between these 2 terms is 6x. Can we do this mentally? Yes, we can. We will look at the 18 and the 24 and find that the highest number I can divide both of them by is 6. Then I'm going to look at the variables we have and take whatever is in common between them. We'll do one more. I'm going to do C. So this was A. Let's do C. We have 15x squared y, and we have 9xy squared. Without a factorization tree, I can tell that 15 is 3 times 5 only. So I don't need a factorization tree for that. This is multiplied by x, multiplied by another x, multiplied by y. And the 9xy squared is actually 3 multiplied by 3. And this is multiplied by x, multiplied by y, multiplied by y again. To find the highest common factor, that should not be a problem. I'm going to take everything that I have in common. I have a 3, nothing else when it comes to numbers. We have an x, and we have y. So the highest common factor between 15x squared y and the 9xy squared is 3xy. If I try to solve this mentally, I will look at which number is the number that I can divide both 15 and 9 by. I will get the 3. Then among the variables, I will take the variable with the least power. I have here x and here x squared. I know that only x is common. Between y and y squared, only y is common because it's repeated only once in one of the terms and twice in the other term. Now I'm going to pause the video, solve the other two questions, do factorization of algebraic expressions in our next video.